Good morning, grade nines. What we're going to do today is take a look at the last, well, I'll say the last PowerPoint of the electricity unit. There's still some stuff that we need to get through in electricity. There's particularly a major assignment, major assignment that we need to get through for the electricity unit, but this will be the last PowerPoint that we do. So the last sort of, let's say the last lesson. But there's still some stuff that you're going to find, some content that you're going to find here in electricity before we move on to space, which is going to be our final unit. The space unit is something that we can kind of go through quick, and that should be a marked booster. So this is really, we're nearing the crescendo of the course. We're pretty much done. I think almost done the hardest material, and that space unit is going to be new, but it's a little bit easier. Okay, even though space is complicated, the unit that we teach, the beauty of that is the unit that we teach in space usually a little bit easier than the other units of science, because it's a little, not that it's not important, but in terms of the curriculum that you have to get through for the rest of high school, the chemistry, biology, and physics units are more important, and the space unit kind of takes a backseat. In life, they're all equally important. You know, in science in general, they're all equally important, but in terms of the curriculum that you have to use, okay, we're nearing the end of the real bulk, the real meat of the course, and the space is a nice little epilogue to that, okay? It's a nice little epilogue to that. All right, so without further ado, let's share my desktop here, and we'll begin this PowerPoint, which of course, based on section 12.2, entitled Using Electrical Energy Wisely. There's going to be some math involved here. So what you'll notice is there are a couple of practice problems here. What I'm going to do is I'm going to gloss over them, and then I'll post a separate video of myself doing those math problems, okay? Now, again, there's a lot of homework here to do, so you know, make sure you budget your time wisely in terms of getting that homework done. Of course, solution should be posted for that as well, but we'll get to that, okay? Here's what we're going to talk about. Now, we've already looked at an electricity bill, or hopefully you took the time to watch me do the assignment that I would have given to you about an electricity bill. I did that, you know, I've left some assignments out, but I wanted to make sure you had exposure to that one because you're going to have to pay electricity bills. So some of this might be familiar to you, but some of it might be a little bit new. So there's some overlap here between those two things, okay? So the amount of electrical energy used in your home depends on, number one, the power ratings of your appliances and devices, okay? The settings on those appliances and devices, and the amount of time each appliance or device is used, okay? And the cost of the electricity depends on the amount of electricity you use, obviously. So what you're paying for depends on how much you use, and the price charged for the electrical energy. So we actually know that. We took a look, when we looked at our electrical bill, that we know about the cost. We've already learned in large part about the cost. Okay, we've taken a look at, well, yeah, your electricity bill tells you how much electricity you've used and charges you per use. And we know that the amount that is charged differs depending on the time of day. We're going to look at that in greater detail in this lesson as well, the time of day. What we don't know is this thing called the kilowatt or the kilowatt hour. We don't know how we're actually measuring electrical energy. We don't know that yet. I glossed over it. I said, we'll worry about it later. When I took a look at that electricity bill, I just said, look, this is the unit. We'll use kilowatt hours. That's the unit. And then I glossed over it. And what we want to do today is take a look at that unit and how we get to that unit, the kilowatt hour. Okay. So electrical power of any appliance, right, any load on a circuit, is the rate at which it uses electrical energy. That's the power. And we measure that in watts. Okay. Now watts, they're actually pretty small. So 1 watt is a very, very small unit. So when we talk about appliances, we actually use kilowatts, okay? Because it's a much larger unit. And so we can use it without using too many decibels, right? And basically, if you're at all familiar with the metric system, then you should recognize kilo means 1,000. That's what kilo means, right? If we have a meter, a kilometer is 1,000 meters. Well, the same way, it works the same way here. We've got a watt, and if we have 1,000 watts, we've got 1 kilowatt, okay? If you check table 12.2, on page 493, you will see power ratings for several appliances. That's how much power they need to do the job that they do, okay? Now, the actual amount kind of differs because you can set appliances differently. You can set your oven to different temperatures. You can set your washing machine to different settings. You can set your even your television has different settings that can increase or decrease the amount of power it needs. Okay, so the power rating is very general, and the actual truth can differ a little bit. Okay, depending on what you want to use the appliance for. Of course, an oven uses less power at 300 degrees than it does at 425 degrees. That makes sense, right? Okay. First thing we want to talk about, and I'm going to do this briefly because this should be a math thing, okay? In math, you should learn about the metric system, and because math is really just a tool that scientists use. Okay, math exists just to help us scientists do our jobs. That's what the purpose of math is. Okay, and measurements are very, very important to that because everything in science has to come down to numbers because that's how we prove things with data. All right, and you should have learned the metric system in math, right? Where basically, you know, if you have a base unit, in other words, the meter, the liter, or the gram, okay, one is for distance, one is for volume, and one is for mass, right? You can move to bigger or smaller units by multiplying or dividing by 10, okay? And so you should have learned how to convert from the meter to the centimeter and the millimeter, and also how to convert from the meter to the kilometer. You should have learned that already. For our purposes, here's what we're going to say. Follow my cursor here. The base unit is the watt, okay? The base unit is the watt. And we actually don't want to use watts. We prefer to use kilowatts, okay? And a kilowatt is 1,000 watts. So in order to convert from the base unit, a watt, we must divide by 1,000 to get to kilowatts. So I told you that I was going to do a couple math problems aside from this video. This is not one of them. This little example here, you can listen to me and I'll tell you what to do, and you can do it on your calculator. So it says, how many kilowatts of electrical energy does a 100-watt light bulb use? Okay, how many kilowatts of electrical energy does a 100-watt light bulb use? And you want to know that in kilowatts, so you take 100 and you divide it by 1,000, okay? Take 100 watts and you divide it by 1,000, and when you do that, you will get 0.1. And that means 100 watts is equal to 0.1 kilowatts. So again, that's 100 divided by 1,000, all right? So, and that's basically it. And if you wanted to go kilowatts to watts, instead of dividing, what do you think you do? You multiply, okay? So that's all we need to know for this lesson. Again, in math, you're going to learn a lot more of this, and then it applies to science. And then when you get into physics, as many of you will, at some point, you're going to do a lot of these conversions, and they're going to become second nature to you. Okay, but for now, we need to know watts to kilowatts, divide by 1,000. That's the bulk of this. And of course, if you want to move the opposite way from kilowatts to watts, which we do a little less often in this particular course, you multiply, all right, by 1,000. So that's to help you. But you know, I think a lot of you have already been through math, grade 9 math, and so that should be familiar to you. Okay. Now, electrical energy. Another factor that affects the amount of electrical energy used in your home is how long each is used. Okay. So electrical energy is the energy used by an appliance at a setting. Okay. And what we do is we multiply the power rating, so the amount of power that the appliance needs, okay, by the length of time that it's used in hours. Okay. And that's why we get this unit for electrical energy. We call it the practical unit, because we know electrical energy is kilowatts, but the practical unit is what you're going to be charged on your electricity bill. And that's based on the energy that you use and the time you use that energy for. Okay. So the practical unit is called the kilowatt hour. Okay. And then what we do is we take that, the amount of energy you used, kilowatt hours, and we multiply it by a price. And the price is in cents per kilowatt hours. And you saw that on the electricity bill very briefly. If you looked at that, and we didn't really talk about it, but if you notice this, the price is, it's 10.8 cents per kilowatt hour, right? So we multiply the energy used by the price per kilowatt hour, and that's how we figure out how much you owe on your bill, okay? Now, when you buy an appliance here in Ontario, actually here in Canada, what you'll find is that each appliance has an EnerGuide label. And that's a label that gives an approximation, an estimate of how much energy an appliance is going to use in a year of normal use. Now, it's not exact. It is, in fact, an estimate. But that gives you an idea to say, okay, if I buy this oven, or if I buy this freezer, or if I buy this whatever, this dishwasher, okay, it's going to use this much energy in a year. And so I can say, well, then I'm going to have to pay roughly this much money on my electricity bill every year to run this appliance. So that's really, and you have to be aware of that because, you know, as a scientist, there's certain things that you have responsibility to do, but just as an adult in general, there are certain things that you're going to have a responsibility to do, and budgeting is one of those things. So when you go to buy an appliance, you should be able to say to yourself, okay, this is how much this appliance is going to cost me to buy today, and this is how much it's going to cost to run this appliance per year that I own this appliance, okay? So in this example here, we have an EnerGuide label for a fridge, okay? And it says it uses 600 kilowatt hours per year, okay? And then underneath that, so if you look here, I'm gonna hope my cursor works here. So 600 kilowatt hours per year, and then underneath there's this bar. And this bar is kind of a comparison bar. It shows you what end of the scale this fridge is at in terms of energy efficiency. And you can see that it's at the far right end. And that kind of says, you know what? It's not a very efficient fridge. And what you want to do is you probably want to look for an appliance, in this case a fridge, that's closer to this end of the bar because it uses less energy. Okay? That's your goal. All right? So again, when am I ever going to use this in real life is a question that we get asked a lot. And guess what? See this stuff right here? You will be using this regularly as an adult, and you would be surprised how often you have to go out and buy appliances, televisions, fridges, stoves, furnaces, well, not furnaces in this case, but air conditioners, dishwashers, washers, dryers, et cetera, et cetera, et cetera. And you have to be aware of what it costs today and what it's going to cost long term, right? Because you know how much money you're going to make at your job, or you do make at your job once you're an adult and you have a job. And you got to be able to fit what you buy within the confines of, hey, I make X amount of dollars per year. I can't go over this amount, right? Okay, so there's a lesson for real life. There's another lesson for real life here. Okay, so you have to have that EnerGuide label so you can make what's called an informed buying decision. That's what we would call what I told you to do on the previous slide, okay? An energy efficient appliance may cost more to purchase than a less efficient model, but will save you money in energy costs over time. So what you want to do is, you know, and hopefully, you know, you're all in the financial position to do this. I would rather, and this is how I make my buying decisions, I would rather pay more upfront. I'd rather go to the store. I'd rather go to Home Depot or whatever and buy an appliance that costs me a little bit more, but will cost me less in the long term because it's more energy efficient. Okay, and that's often the case. Often the case, you look at two fridges and you'll say, well, this one is less energy efficient. It uses more energy. Why would I buy it? Well, you'll buy it because it's cheaper. And I don't want you to do that. I want the advice that I will give you is to spend a little bit more upfront, okay, and buy a more energy efficient appliance because it will cost you less on your electricity bill over time. If you have a fridge for 10 years, that's a long time, and the savings will add up over that period of time. It's what's called being, if you buy that cheaper fridge, okay, you buy the cheaper fridge because it's cheaper, but it's less energy efficient, then you're being penny wise and pound foolish. Of course, that turn of phrase comes from England, where their currency is the pound, and so they're worried about saving pennies, but they're losing pounds, as in their money. So it's penny wise, dollar foolish, right? I'd rather be dollar wise, so I'll spend a little more up front and get a more energy efficient appliance. So to help you choose, okay, certain appliances are actually labeled with an Energy Star rating, which is almost like a certification that's saying, you know what, this product, take a closer look because it's actually really energy efficient. So when you go to buy an appliance, look for a label that looks kind of like this, Energy Star, and that's saying, hey, this is a good appliance. And this is a good thing here in Canada. I don't know that all countries have a system like this. So we're really lucky that that the government has, you know, sometimes I'm critical of things the government does, and sometimes I appreciate things the government does, and so it works in democracy. This is one of those things that I really do appreciate, is that the government mandates that if you're going to sell an appliance in Canada, you have to have the EnerGuide label, and you can submit your appliance for certification for Energy Star and be labeled an Energy Star appliance, and that helps us make an informed buying decision and helps us be more energy efficient. It's better for our wallets, and of course it's better for the environment, right? It's better for the environment because if we use less energy, right, then we don't have to generate as much energy, and the impact on the environment that's caused by generating energy is lowered. Okay, here in Hamilton, we get our energy from Niagara Falls. It's hydroelectric, so it's renewable, and it is relatively low impact in terms of emissions. But there are a lot of places in Ontario and in North America and around the world that primarily get their energy from burning coal, right? And in that case, you want to make sure you're using as little energy as possible, because that coal has a huge impact, a huge negative impact, I should say, on our environment. But I'm kind of getting ahead of myself here. Okay. This is a problem, cost of energy sample problem, that I'm going to gloss over now, but you're going to finish watching this PowerPoint and you'll see that I've already posted a video with the solution to this problem. So just if you want to pause it and then watch another YouTube video with me solving this problem, then go right ahead, be my guest. Or we can just move forward. It's up to you, but just know that I'm not solving this here. I'm solving it in another video, so it'll be there posted in the LMS for you to take a look at. Okay, so just we're gonna gloss over it right now, but this is the type of problem that you might see on a well, first of all, you would have seen it on another assignment that I was going to post, or I would have handed out with this particular lesson in school. I'm probably not going to assign that. What I'm probably going to do is post that assignment and say, listen, try this. I would have marked you on this. I'm not marking it on you now, but you need to know how to do it. It's worth knowing. So I'm going to post it for you and not mark it. I'm just going to kind of say, give it a shot. Okay. So, but you will be tested on this on the test and possibly whatever cumulative assignment that we do. Okay. So you got to get good at these. All right. So if you want, pause, go look at the next YouTube video. If not, we'll finish off this PowerPoint and then you can watch that video next and fill this in on your own. Okay. We talked about this already when we looked at that electricity bill in the last lesson, time of use pricing. Okay. And basically what it says is we charge, well, we don't charge, I don't charge, but the electricity company charges a different amount depending on the time of day you're using electricity. So let's look at this first graph because it actually changes throughout the year. Okay, so in the winter, between November, okay, and the end of April, okay, you're on the winter weekday schedule. Okay, and what that means is from 9 p.m. to 7 a.m. you're on off-peak hours. Why? Because everybody's sleeping. Lights are off, TVs are well. Most people are in bed, particularly between 11 and 7, but it starts at 9. Okay, electricity is being used less because we keep less lights on. We're less people are watching TV in general. Less people are cooking because dinner is already over, and so they charge less for electricity because there's less demand. Okay, if I wanted to make the most amount of money, I would charge the most amount of money when my product was in the most demand. Okay, so This is the off-peak time, and it's when energy is the cheapest. Now, these prices, not accurate to today. Okay, I don't have my own electricity bill in front of me right now. I actually should have pulled it out just to check, um, but not necessarily accurate to today. But the ratio is accurate. So, off-peak being less expensive than peak, being less expensive than on-peak is what you need to bear in mind. So during the winter, between November and April, the mid-peak is between 11 a.m. and 5 p.m. And that's because many people are off at work, but some people are at home, and so there's kind of a mid demand on electricity for the average homeowner. Okay. The on-peak times are early in the morning when everybody's getting ready for work. Okay. And in the evenings, when everybody's cooking dinner, everybody's relaxing, watching TV, reading, the lights are on, everybody's going through their business at home. And so it makes sense during these two periods of time, this is when the electricity is most expensive. Okay. Now, when we switch to the summer, the off-peak times actually increase. What happens in the summer that might mean we demand less electricity in the evenings? Well, the day becomes longer. Remember, the sun doesn't set until maybe 9 o'clock at the height of the summer. And so our lights aren't on as much. And so there's less demand on electricity. And that's why we get more off-peak hours in the summer. Okay. But when do we notice on-peak is? All of a sudden, on-peak time is the middle of the day. And why is that? Because it's hottest in the middle of the day during the summer, and we're all running our air conditioners and fans in the middle of the day, and that's the air conditioner is an enormous draw on electricity. It is not efficient at all to run an air conditioner. Okay, and that's why in my home, I like to, if I can, open the windows on a breezy day instead of using the air conditioner. Right? Because when you just run that air conditioner constantly, it's hugely expensive, it's hugely inefficient. And the electricity company knows that, and they charge you the most. Okay? They charge you the most. All right? Now, what happens on the weekend and on stat holidays, Christmas Day, Boxing Day, Victoria Day was just passed. Those are stat holidays. Okay? It's all off-peak time. So that's why, when is a good time to do your laundry? You use your washer and dryer. Well, off-peak hours, after 7 or after 9, or get it done on the weekend when electricity is cheapest. And that's my advice. You got to budget your time so you can budget your money. Okay, you got to budget your time. You got to budget your money. Now, the last thing I want to say about this, okay? The last thing I want to say about this, other than the adjustment as they shift when these on and off peak times are, depending on the seasons, the last thing I want to say is power plants have a maximum capacity. In other words, they can only generate so much electricity, and it's a lot. It's a huge, 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 huge amount, okay? But there is an upper limit. And so what off-peak and on-peak hours do is they encourage people to use a little less electricity at certain times and shift their electricity to other times. And what that does is, instead of everybody trying to wash their clothes at the same time or use their dryers at the same time, that's too much draw on electricity. And so they have people spread out their electricity use throughout the day, and that way the power generator, in our case, would be in Niagara Falls, right, doesn't break capacity. Because when we overdo it, when we use too much electricity as a district, as Southern Ontario, we get power outages. Okay, and so to avoid that, to avoid straining the infrastructure, the off-peak and on-peak hours encourage us to use less electricity when it's most in demand and use a little more electricity when it's less in demand, and that spreads out the capacity of our electrical generators. Okay, so that's the goal there. All right, so save your money when you're an adult, plan. All right, phantom loads. If you have a thing and it's plugged in, but you're not using it, it's still drawing a little bit of electricity. Okay, and we call that a phantom load. And in fact, the average home has a phantom load of 50 watts. Doesn't seem like a lot, but it adds up over the course of a year. Okay, that adds up. What's the biggest one for you guys? Probably your cell phone chargers. If you leave your cell phone charger plugged in, right, that is a phantom load. It's drawing just a little bit of current, okay? It's drawing just a little bit of power. Okay, not a lot, but over the course of a year, it certainly adds up. Okay, so one of the pieces of advice that we can give you is if you're not using an appliance and you can, unplug it. You know, your stove and your dryer and your dishwasher, well, you can't unplug those because they're large, they're heavy. You can't unplug them. But your cell phone charger, you can unplug when you're not using it. Okay, your toaster, you can unplug when you're not using it. And that'll save you just a little bit. But every, you know, especially in places where they don't have renewable energy or they're not using renewable energy because they're archaic, it's a good idea because it's more efficient, it's better for the environment. And, you know, it might save you a couple bucks on your electricity bill one day to just unplug your charger, unplug your PlayStation when you're not using it, right? Unplug your Nintendo Switch when you're not using it, you know, because it is drawing power. Okay, and that's what we call a phantom load because it is using electricity even though you're not using it. Okay, even if it's off, even if you hit the off button on your Xbox, whatever Xbox we're on right now, Xbox 360 or whatever, if you turn it off, it's still drawing current even though you're not using it. So be mindful of that. Okay, one of the things we like to talk about is efficiency, and that's a ratio. And what it compares is the useful energy that's output from a device, and we compare it to the energy that we have to put into that device to run it. Okay. Now, we've talked about power, electrical power in watts, but the actual scientific unit for energy is the joule. It's not power, it's energy. Okay. And when we talk about efficiency, we want to use energy. So we want to use joules. And you're going to learn more about the comparison between watts and joules in physics courses later. Okay. But when we talk about just energy and energy efficiency, we want to make sure we're using the unit joule. Okay. So a joule is equivalent to 1 watt operating for 1 second. Okay, so 1 joule is 1 watt second. So you can see that right here, 1 watt second. Notice I didn't say per, it's not per second, it's 1 watt second. If you see a slash, it's per second. If you see this little dot, it means 1 watt second, okay, because we're multiplying. Okay, it's not a division statement, it's not per, it's being multiplied. And so 1 kilojoule is 1 kilowatt per second, not per second, 1 kilowatt second, okay? So in order to obtain the total energy input of a device in kilojoules, we must multiply its power in kilowatts, okay, by the time it is on. All right, so that statement, that means nothing to you right now. It shouldn't mean anything to you right now because we're going to do a sample problem. Again, we're not going to do it in this, this particular video. I'm going to post a video right now, right after this one, in which we take a look at the 2 sample problems that we've done. And when we do those 2 sample problems, you will see that this particular sentence here, multiplying or going from kilowatts to kilojoules and multiplying by seconds, it'll make sense when I do it in the problem. Because I think it doesn't make sense just reading it. I think it makes better sense when you're actually doing it in a sample problem. So don't worry if you don't understand it here. When we do this problem in the next video, which I'm going to post right away, okay, that's when it's going to matter. All right. So please, you know, I'm not going to say so long right now because I know you're going to turn off this video and move right on to the next one. In this case, you have to watch the next video immediately. So I'm not going to say bye. I'm not going to say take care. I'm not going to say be safe because I know you're going to turn on the next video. And at the end of that video, I'll make sure to let you know to be safe and take care of yourselves. Okay. So I'll see you again in the next video immediately. Okay, guys?